folks, it's Bass Action back in action. In this video, I want to talk through the warm-up for the day 3 notes for those of you who were absent or for my group who just had the shortened class period. I thought an explanation of this warm-up might be helpful because there's a lot happening here. So you'll notice I already have it all filled out, and I'm just going to talk through what I did so that you can hear the logic behind all the various pieces. All right, starting here with our example 1, part A, listing all the possible rational zeros. Keep in mind that if you have a polynomial such as this one that does not factor, okay, so we've got these 4 terms, we can see it's not going to factor by grouping, and if you had that, and without the rational zero theorem, you would have nowhere to start other than to just start picking numbers from the entire bucket of real numbers. Then the rational zero theorem takes that infinitely sized bucket of real numbers and allows us to narrow it down to this small group of numbers. Now, this plus or minus here is very important. You would either need to list all of these values and then list them all again with the negatives, or make sure to put that plus or minus, because this plus or minus is definitely worth points because it is indicating the whole other half of the values. And how you create these is really up to you. We're going to have our factors of 7 and our factors of 6, and then how you break it down is how you want to organize it. So I always list the first 2, and then I take the first number and I just put it over each one. So that's one way. So I could do like a 1/2 and a 1/3 and a 1/6, or you can look how I wrote this one where I did a 1/2 and I did a 7/2, and then I went back and I did a 1/3 and a 7/3. That doesn't really make much difference. Then you could certainly go through and you could test all of these possible numbers, but another way to help us narrow it down is to take those and put them on a number line, okay? And this is going to allow us to use the intermediate value theorem. So what I did is I just gave myself a couple whole numbers here, and then I started placing my fractional values in the appropriate regions. So 1/2 is between 0 and 1. 7/2 is going to be 3.5, so it's out here. 1/3, it goes here. My 7/3 is going to be between 2 and 3. 1/6 here, and 7/6 would go here. So now we can see how these are laid out. Again, just like this plus or minus, we could make an identical number line in the negative direction if we wanted to as well. It's really a personal preference. I don't typically grade this number line. Then what we can do is we can choose a place to start. Now, the way that we can test how to start is using the intermediate value theorem. So if we took the 1 and we tested and we found what is P of 1 and we evaluated, and then we evaluated what did we get for P of 2, what we would notice is that there's a sign change between here and here. So the better place for us to do our test is to start with this 7/6. So let's just back it up. If we did P of 0, we would find that that's a negative number. If we did P of 1, we would see that we still had a negative number, and you can pause the video and test it. And then if we did P of 2, we're now going to have a positive number. So we're going to go from negative to something positive, which means our graph has to cross the x-axis between here and here. Now, it doesn't guarantee that 7/6 is going to be our answer. It's possible that there's a real solution between 1 and 2 that's something irrational, okay? Some type of a square root possibly. We don't know, but this is a great place to start our test. So I took that 7/6 and I set up my synthetic division, and sure enough, I got the 0. That means that I could take this remaining polynomial, this reduced polynomial, and you can see I set that up right here. I divided everything by 6, and then I solved it. Now, we usually talk about using completing the square, but I'll be honest, on this particular problem, it doesn't really make much difference whether you did completing the square or the quadratic formula. All the coefficients are 1. It doesn't make any difference which one you do. But when we solve this, we get our zeros of -1 plus or minus I square root of 3 over 2. So when we go to graph and create our sketch, we can do our end behavior, our y-intercept that came from the constant, our one real zero, that was the 7/6, and then we just sketch it in. Again, we've talked about this before. You might put a little extra turn in here. That's okay, because you won't know where those turns should or should not be until you get to calculus. Okay, so that takes care of example 1. Example 2 has a special little detail in it, and the important thing about example 2 is you'll notice that this polynomial is set up as an equation and not just a function, not just as function notation. And the intermediate value theorem has an extra detail in it that you likely missed in the previous video, and it mentions that all of the coefficients on the polynomial must be integers. They must be whole numbers to use the intermediate value theorem. So since this is an equation set equal to 0, I cleared the fractions by multiplying by 2 and created a new polynomial that has all those integer coefficients so that I could go through and do my rational zero function and the intermediate value theorem. So again, I took my factors of 4 and my factors of 2 and I created my list of possibilities, remembering the plus or minus. Then, if we have this extra note that's up here that says that this polynomial has no integer solutions, when I look then at these list of possibilities, I know the 1's not going to work, the 2's not going to work, the 4's not going to work. So the only possibility of what might work is the 1/2. So this case I did do both sides because I only had 2 numbers. So I have the -1/2 and the +1/2. And again, if I test my intermediate value theorem, what I'm going to notice is that at a -1, the polynomial is negative. At 0, the polynomial is negative. It'll be that y-intercept. And at 1, the polynomial will be positive. So I get my sign change between 0 and 1. So that's why I knew to start with the 1/2. So when I started with that 1/2, okay, when I started with that 1/2, I set up my synthetic division. Sure enough, I got that 0. That then gave me this nice reduced polynomial. Then I set this one equal, the first one equal to 0, and you'll notice that I already divided through by 2. So if I took the 2x squared plus the 4x plus 8 equals 0, I just immediately divided through by 2 to clean that up. This one is much nicer to do a completing the square, so you can see that was the strategy that I did. And these are now my imaginary solutions, and thus I could create my graph. So hopefully that helps on how to understand combining the rational zero theorem and the intermediate value theorem a little bit better for you. And then I've got one more example in the next video if you need a little bit more explanation.